Hello, my friend. Welcome to my channel. So today I'm going to talk about a problem related to hypothesized testing for population proportion. This is the example. A dietitian claims that 60% of people are trying to avoid trans fats in their diets. She randomly selected 200 people and found that 128 people stated that they were trying to avoid trans fat in their diets. At alpha equals 0.05, is there enough evidence to reject the claim? So let's identify the claim here. A dietitian claims that 60% of people are trying to avoid trans fats. As you can see, the claim is exactly equals to 60%. So let's write down null hypothesis and alternative hypothesis. Since this one is exactly equals, it is null hypothesis in this case. I'm going to use population proportion notation is simple P equals 0.60. And then my alternative hypothesis is not equal. Here the claim is the null hypothesis. Okay, so let's identify all the information here. A randomly selected 200 people. So sample size is 200. And found that 120 people stated that they were trying to avoid trans fat. So that X value is 128. So characteristic of interest is the number of people avoid trans fat in their diet. So X value is 128. So then sample proportion, which is P hat, equals X divided by sample size. 128 divided by 200, which is 0.64. Now, let's look at the test statistic formula for this testing. So we are going to use z-scores. Z naught equals p hat minus p over square root of p times q over n. So as you can see, we need to have p and q. We already know p value. So the p value equals 0.60. Then you can calculate q value. Q is 1 minus p. So 1 minus 0.60, which is 0.40. Now we know everything. We can calculate this value. P hat is 0.64 minus 0.60 divided by square root of 0.60 times 0.40 divided by 200. So this value is 1.15. Now this is your test statistic value. Here I'm going to use two methods. One is critical value method and the p-value method. Let's look at critical value method. We need to find critical values here. Alpha is 0.05. Since this is two-tailed, if you look at the alternative hypothesis, it is two-tailed. Two-tailed test, right? So we need alpha by 2, which is 0.05 divided by 2, 0.025. Then you have two tails in this problem. This tail is 0.025. This tail 0.025. Then we can see that two cutoff values. One is negative, the other one is positive. Two critical values. So let's find the negative critical value because it is easy. It's in the left tail, right? So z-score table, locate 0.025 inside the table and then look at the z-score. You will see it is negative 1.9 and the second decimal place 6. So this critical value is negative 1.96. Since this is symmetric around 0, then your positive value is 1.96. Now we have these two critical values. So let's look at the p-value method. To find the p-value, we need to consider both tails, right? Look at the test statistic. It is a large positive value. If you look at the distribution, it is somewhere around here, right? So we can find this tail. So here we can consider extreme cases like this, but we need both tails. Since this is symmetric, you can consider this tail or this tail. You can find. I think this one is easily fine. I'm going to use the negative 1.15 to find the p-value. So p-value, p-value equals the 2 times. We need to consider both tails, right? 2 times probability of z scores less than, let's say, negative 1.15, right? Or you can consider this value exactly. Then you should write 2 times probability. If you use the positive value, the 1.15 is 1 minus probability z scores greater than 1.15. You can use either of these cases, right? Let's find probability less than negative 1.15. So if you look at the table, z-score table, negative 1.1, second decimal place is 5. So you will see the value over here is 0.1251. So you need to multiply it by 2. So I'm looking for this one. You can use this one if you want. You will get the same answer, right? So here 2 times, I'm going to have this one, right? So that is, p-value is this much, right? So we have to double it because we need both tails. So p-value is 0.2502. And then let's make the decision of this test. As you can see, we have two critical values, negative 1.96, positive 1.96. These are critical regions. And this is non-critical region, right? Look at the test statistic value. It is somewhere around here, right? It falls in the non-critical region. So we fail to reject the null because your test statistic value is between 1.96 like this, right? Positive 1.96. So it falls in the non-critical region. So we fail to reject the null. So now compare the p-value. P-value equals 0.2502 and alpha equals 0.05. So we compare these two numbers. As you can see, p-value is large. So if p-value is larger than alpha, then we fail to reject the null. So in both cases, we fail to reject the null. So now you can write down the conclusion. There is not enough evidence. In this case, since claim is null hypothesized, we write down there is not enough evidence to reject the claim that 60% of people are trying to avoid trans fat. Okay, so that's the conclusion. So I hope you understand this problem. If you have questions or concern, please comment. If you wanna see more videos like this, please subscribe to my channel. Thank you so much for watching this video. Bye.